Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, welcome to Industrial Talk. Thank you very much for joining the #1 industrial-related podcast that celebrates industry professionals such as yourself around the world. You're bold, brave, you dare greatly, you innovate, you collaborate, you solve problems each and every day. You are making the world a better place. That's why we celebrate you on Industrial Talk. Thank you very much for what you do. You are the heroes in this story. We're brought to you by Siemens Smart Infrastructure and Grid Software. Go out to Siemens.com. Please do that. Find out more. Great people, great company, great solutions. Siemens.com. Make it happen, Captain. Put that on your to-do list. All right, we're broadcasting from DistribuTech. It's in Dallas. It's massive. It's gargantuan. That's the first time I used gargantuan, but it is the first time. Gargantuan. And if you're in the world of utilities, let's say distribution, transmission, device manufacturing, asset management, doggone it, you need to be here. If you're not here, you're missing out on all the cool kids. That's what it's all about. Speaking of cool kids, we have two in the hot seat, Robert Brook and Brian Reed. We're going to be talking about data and how to manage that data. And by the way, just FYI, see this card? That card? It's not just any card. It's a piece of wood. It is actual wood. And it's not just any wood. It's 2-ply cherry. Right there. It says it on the back. It's cool. Brian gave it to me. I like Brian. All right, let's get cracking. All right. Guys having a good conference?
Yeah, so far.
Yeah,
good.
Fantastic. Yeah? It's pretty rare you get this number of people together at the same place at the same time.
It's huge. It's massive. This event's been going on for years, right? And I was shocked at the size.
Yeah.
And it's quite the time of it's the new Renaissance. I mean, it's the utilities and all of the management of those assets. It's pretty cool stuff. And the demand for power, it's going through the roof. I want to be younger again. I just want to dabble in it. Now I just talk to you guys. Help me make sense of that. All right. Before we get into the conversation about, it's Osmose, by the way. What's your company's name?
We're called NIRA.
NIRA?
Software. Yeah.
Yeah.
Yeah, like near a pole, near a tree.
NIRA.
Oh,
thank you. Is it Greek for something?
No, it's one of those times where you have to find a new creative name because most of those names have been used, and this one actually is pretty relevant.
I was just going to say, NIRA. That's I can. Good job on that. Now I can remember that forever. Yeah. Well, anyway, before we get going, I'm gonna take it over to you, Brian. Give us a little background on who you are.
Okay, great. With Osmose Utility Services, I'm Director of Product Management for our technical services. I've been in the industry for nearly 25 years, helping customers solve their problems related to pole inspection, maintenance, and data.
I used to always go. This is the truth. Back to my utility days, whenever I would go to a pole, getting ready to climb it, I would always look for that butt test and make sure that it's like, okay, cool. Look at the nail. Everything was. I would do that. You kept me safe.
Yeah. Well, we've been around since 1934, providing these services to utilities.
Amazing.
Yeah.
I mean, it's just amazing.
It's older than you, right?
What's that?
Older than you, right?
A few years, just a couple years. I started when I was. Never mind. All right, back at you, Robert. Give us a little background on who you are.
Sure. That's a good question. I've often thought about.
We go to the same barber. Let's put it that way.
Yeah, I've been in the industry for 30 some odd years in a variety of shapes and forms, but I think the consistency through most of that is trying to take aspects of technology and help organizations make better decisions with it. That's really the premise behind what NIRA does now, is to really take the information that those organizations have and put it in a form that allows for informed decision making.
See, this is interesting. Utilities have collected data forever. There's just, and then of course, the providers of solutions and services, same thing. I mean, because it's been a heavily regulated business, you had to you couldn't pencil whip You had to do it effectively. But now we're at a point where we can begin mining that data. Explain to us a little bit about the relationship that NIRA has with Osmose, and of course Osmose has with NIRA and all of that stuff. I throw it to you.
Sure.
Give it to me, Brian.
Yeah, sure, thanks, Scott. So we've been familiar with NIRA for a few years, and one of the things that I think we both recognized in the industry is it's often difficult for utilities to move information across different aspects of their business. So GIS folks versus pole inspection and maintenance or pole restoration.
Are they siloed?
They're a little bit siloed, yeah. So there's a lot of good information, and what we saw this partnership as an opportunity for was to really have a platform that could consolidate that information into one source, be able to synchronize that with the GIS records so that you had enhanced data that you could use to really improve your risk-based decision making. And the NIRA platform was a perfect match for us to do that.
Okay, so I'm going to send you a bunch of data. Robert, I'm going to, is NIRA's platform somewhat, shall I say, agnostic? You can take data and then begin making sense out of it, or normalize it, or take us through what that looks like. You're receiving it from Osmose or whatever, and
Sure.
Go for it.
So with almost all of our customers, what we start off with is by building what we call a digital network model. And we're taking a variety of data sets. Usually we'll start with something like LiDAR. Because we're doing engineering analysis, we need something that's highly accurate. So we'll combine that with GIS information, construction standards that come from an organization, and we build this model, but it doesn't look like what you'd have. It looks like a GIS systems model, but it has an engineering and physics-based relationship between the assets. So it's about as close to an identical replica of those assets in the field that you can have in your hands. So if you move a pole and the insulator angle changes, line tension changes, and the way those assets interact with the world around it changes, and we use that for simulation. But in models, the outcome that you get from it is only really as good as the depth and strength of the data that you put into it. And part of what's really exciting to us about this relationship with Osmose is we have this sort of state-of-the-art, high-end modeling environment that we can use to help organizations make informed decisions about what they do. It's only as good, really, as the quality, the content that comes into it. And Osmose has these phenomenal, deep asset records, years of inspection that we can take and bring into the platform that A, help us fill out the information that we're using to run those analyses, but B, actually give us a very granular, very accurate level of content to ensure that the results we're giving to people that they're making decisions on are highly valuable.
All right, Brian, take us through a use case. If I'm a utility, and I've already have this relationship that goes back because many years, and I'm very familiar with Osmose. Take us through a use case of this particular NIRA solution in Osmose and bringing it all together. If I'm a utility, what are you talking to me about?
Sure, I think initially I think a really good use case is the strategic resiliency plans that most Texas utilities are putting together. Being able to take and look at a network-wide model, enrich that data with historical pole records, pole degradation models, soil models, all the information that we typically collect, and then to leverage that to identify and prioritize the most important assets that need structure upgrades to help support those the heavy wind loads or storm loads that many utilities are starting to experience, and that regulators are becoming more focused on ensuring utilities are able to withstand certain storm conditions. So the use case for us is a high-level network model like NIRA can produce, enhanced with the data and analytics, or the data and degradation models that we find in the field, and verify that data, drive solutions that are affordable to a utility and help them achieve their strategic resiliency plans.
So I'm Scott Utility. How do I receive that tactical information? Like, how do I do it? I mean, what am I looking at?
So that's the NIRA platform. So they have an instance that is installed, and the utility has access to that. They can perform the simulations, take a look and prioritize their circuits, But within that, there's the ability to go down to a really granular level and look at a detailed pole loading model, wind and ice model for a particular pole, size a solution for that rather than replacing the structure, identify a steel truss upgrade that can improve the class strength of that pole. So I think the NIRA platform really allows the pole owner to help self-serve themselves through that process and identify and prioritize the circuits and the structures they need to update. There's going to be a level of financial analysis that goes with that to ensure that it's meeting their capital budgets and their budget restraints for performing those upgrades. But there's a lot of self-service there. But we're always there to help as a steward for the utility to identify and help really pick those solutions, which are going to be most effective, most affordable, and in the quickest amount of time for them to be able to achieve their goals.
Robert, so I'm able to run simulations. I can take the data, and it goes. You guys do more than just poles.
We do.
So it's pretty comprehensive.
It can be, right?
Right. But you're starting with poles?
We're starting with poles. That's kind of the easy one.
Yeah, it's the low hanging fruit.
It's the easy one to do. But anything from, I would say, poles to overhead condition to pole loading models, make ready engine. I mean, there's a whole number of use cases that this partnership can pursue.
But we're looking at poles. So I go into your system. You have some sort of user interface, I would imagine, and then I can run simulations. And how quickly can you take the data that is available from Osmose and then begin to spin out meaningful insights?
Pretty quickly. I think tracking back for just a second. First of all, I think one of the things that's really appealing about most of this is it's a combination of two sort of beautiful environments, right? It's this depth of data, and if you have a chance to see what our platform looks like, it'd blow your hat off. It's just a cool environment to work in. I think it gives you great insights, it's very visual, and it combines it with outcomes, right? So pulling data into the platform is a very fast process, and it allows us to, if we go back to that pole situation and use that as maybe one of the assets that we look at, we can do an individual pole analysis. The same as you could see a variety of other applications do. But we also have a scalability to the platform where we can run that same analysis across millions of assets. So, if we're going to run, say, a pole loading equation, we can look at a single pole and be able to run that on that, or we can decide to run across an operating area, a subset of that unit, the entire system as a whole, and be able to perform that same analysis against it. And that's something that, could take an organization years to be able to do. So there's this huge efficiency associated with the scale of what we can do. So people like using the platform, first of all, because I think they get good content, right? They get a really nice visual experience to be able to work with it, but the outcomes are what make people come back into it. So you can see that in front of you in sort of a GIS style environment, a three-dimensional GIS style environment, but it's combined with tabular outputs that you can use. So really, whichever form you need to have to communicate inside of the organization is available out of the tool.
So I can look at the total, sort of the health of a whole line. Just saying, okay, here's the whole line, here's the whole circuit, A to B, termination to termination, wherever it is, and then be able to determine. And you're looking at distribution as well as transmission pole. You're looking at all poles.
Yep, and you can run. So as an example, the great beauty of it is to simulate what occurs when something happens, right? So you can see what those assets are, and through attributes you can understand health associated with it. But you can run a simulation where you can say, what does this look like if it's 40 mile an hour wind, 50 mile an hour wind? What's the sag and sway associated with that cable? Does it come in contact or come inside of the buffer area for vegetation?
Did you say cable?
Yeah, like
the conductor?
Yep. Yeah, how it sways back and forth.
Does Osmose do that too? The conductor? The sag?
We don't. We can analyze that, but we don't touch that.
Because that.
But they're critical to the process.
Yeah, they're huge.
That information is what makes what we do real, right? So, those detailed records that they have help us ensure that the pole, the way it reacts to winds, is actually correct, right?
Yeah, because when we would reconductor lines, all right, We would have, of course, the table, and then you'd go in there and you'd a distance, and you'd sort of come up with, you didn't do it real sophisticated. You'd run down to the other line, and then you'd put a mark down there, and then you try to identify, that looks good from a SAG perspective. But the reason for that is, of course, you didn't want there's a in heavily loaded areas, you didn't want to snap holes or whatever. You had to be careful.
And I can tell you exactly what it would look like. I can tell you under what temperature, how far it would sag. Yeah. Under what line load, how far it would sag. Under a 25 mile an hour wind, how it would go back and forth. And that's just one of the examples as to how we did it. The use cases extend from something that we would look at as simple like vegetation management all the way through what Brian talked about earlier, which is investment strategies. How you look at the outcome of analyses, which we would call a backcast. Yeah. What did you do inside of there? Did you replace poles? Did you do bracing solutions? How did you address the challenges that were coming in the system, and what was the effectiveness of it? And then use that as the guide to determine how you do investment as you go forward, and create all the quantifiable information that you need to put into a rate case or a capital submission to ensure that your ask is justified.
How do you keep current with the data? Let's say that it's dynamic out there. This pole was replaced, car hit it, whatever. There's activity. It's very dynamic out there. How do you keep current so that the model stays current?
So it really comes down to being from a utility standpoint, being proactive and being out there and capturing that information, along with a good as-built capture process. So as new communication facilities are attached to poles, with the broadband build-outs that are occurring, that's an additional cable on a pole. That's a good tribute load. So making sure that data, after that's installed, gets back. It's really comes down to I don't know the right word, but discipline in making sure that utilities update those systems.
It's a change management. You're having to deal with the culture that exists in ensuring that, okay, I've invested this time, energy, and effort for this solution to be able to see and have the insights that I need into my asset base, and then be able to make sure that the individuals in the field, definitely update the planners, all of this. There's a coordination that has to happen to make sure that model stays current.
And there's two tiers to what you might think of currency, right? I mean, the first one, if we think about it from a human perspective, you're an individual, you were born, you're here, right? So that's the same sort of thing we look at from utility assets, that what are the poles, what's the infrastructure, where it exists, right? But I would hazard a guess that you don't look the same today as you did 40 years ago, right? So that second factor associated with it is, how does it change through time, right? How does Mother Nature's attempt to pull it apart do that? And that's really where Osmose excels, right? Is helping us understand the nuances of the condition of those pieces of equipment. And part of what this whole thing, like this forecasting strategy does, is it helps companies right fit their spend associated with their asset, but also direct the money into inspection that has to be there, so that we understand what's there, but also what condition it's in. And those are critical factors for being able to manage equipment.
Brian, I hate to do it because I never really knew. So what's the rotation? What's the frequency of testing these poles? How you come back, everything's good. You take your auger, you drill it, it's solid, it's good. I plug it, I'm on to the next one, right? But then there's the time when I auger it, there's hollow. How do you?
There are some good guidelines around that.
Yeah.
So.
Well, I hope so, because you guys have been around for 350 years?
That's right. So
before power?
So there are what they call decay hazard zones. There's a decay hazard zone map for the United States, which kind of dictates how often you should really think about doing an inspection. And then the preservative treatments are really the key part of that. It's you think about a brand new utility pole has been treated, whether it was a CCA or gas or cell-on or whatever some of the old treatments might have been. Over time, the effectiveness of that treatment wears off and allows decay fungi to attack and reduce the wood strength. So just like we have booster shots for different things, a pole needs a booster shot to bring that preservative level up to a point where it can repel and kill decay fungi, which is really what eats away at the wood pole. So in the south here, in probably Florida, the southeast, Texas,
Louisiana.
Yeah, Louisiana, you're probably
It's
in
all
that.
swamp.
It's probably in that 7 to 10 year range, and that's when we design the preservative treatments, which we manufacture, research, develop, and design those treatments. We target those aggressive inspection requirements and times that we need to come back. As you move further north, you can inspect less often, but in general, a general rule of thumb is once every 10 years. Do an inspection, apply the remedial treatments, and then you're good for the next one.
And you can take that. You're doing the inspections. You upload it into the NIRA platform. Mm-hmm. You're not really dependent, theoretically. You're not dependent on the utilities to make sure that data is current. That's all a part of your service offer.
The service that we offer, and then we've also over the years developed. We've developed some what we call pole degradation models, where we can actually predict future decay based on soil conditions, the decay hazard zone, and weather environments, and the measured strength that we had the last time we were there.
That's cool. That is real cool, Brian. How do people get a hold of you? They want to find out more. What's the best way?
You can just go to my LinkedIn page and tag me for a reply there.
There you go. And Robert, same thing?
Same thing. LinkedIn's the place to find all of us.
You guys are great. That's exciting stuff. Now I've all, again, I knew Osmose and all of that good stuff that's associated with it, and now you've made me a better person. You both have made me a better person. That's cool stuff, by the way, FYI.
Great.
It's exciting. Exciting time to be alive. Thank you very much for being a part of Industrial Talk.
Thanks for having us, Scott. Appreciate it.
Thank you, Scott.
Cool
Good meeting
conversation.
you. Thank you.
All right, listeners, we're going to have all the contact information for these two gents out on Industrial Talk. Fear not, you'll be able to reach out. Cool solution. Love it. Love it. It's just cool stuff. We're broadcasting from DistribuTech. Dallas, Texas is the location. All the cool kids are hanging out here. You need to be here. You need to put it on your calendar. And we're also brought to you by Siemens Smart Infrastructure and Grid Software. Go out to Siemens.com. Great people, great company, and definitely great solutions. Go out to Siemens.com. Thank you very much. We're going to be wrapping it up on the other side. Stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
Yeah, Brian Reed, Robert Brook. That was a great conversation. Boy, did that bring back memories of me just sort of climbing towers and poles and all that stuff, specifically poles. I knew Osmose from that experience, and you always trusted what they did. They evaluated the health of that pole, and they got it right. They did. Poles weren't just falling over. Yeah, so that company's just been spectacular, brought back a lot of great memories. Industrial Talk is here for you. Of course, we're a marketing and sales organization that helps you amplify your message and get the attention you need to succeed in this renaissance of industry. It's happening. Don't miss out. Figure it out, because it's important. We've got the team in place, and we understand industry in a big way. All right, be bold, be brave, dare greatly. Hang out with Robert and Brian. Change the world. We're going to have another great conversation shortly, so stay tuned.